Introduction. The liquid limit is defined as the moisture content corresponding to a cone penetration of 20 mm. Objective Atterberg limit test. The Atterberg limits test is a classification test used to determine the moisture content at which fine-grained clay and seed soils transition between the different phases. The test for the Atterberg limits is performed on the fraction of soil that will pass through a number 40 or 0.425 mm sieve. The equipment: Penetrometer apparatus, plastic limit set, electronic scale. Then we move to experiment method or procedure. A sample weighing at least 200 grams shall be taken from material passing the 425 meter BS test sieve. Then, the sample shall be placed on the flat surface and mixed thoroughly for 10 minutes with distilled water using the blade knife until the mass becomes a thick homogeneous paste. The soil shall then be pushed into a cup with a palette knife, taking care not to trap air. The excess soil shall be struck off and leveled off by a smooth surface. The Penetrometer cone shall be lowered so that it just touches the surface of the soil. When the cone is in correct position, a slight movement of the cup will just mark the surface of the soil and the reading of radar gauge shall be noted to the nearest 0.1 mm. The cone shall then be released for a period of 5+1 seconds. Care should be taken not to jack the apparatus during these operations. After the cone has been locked in position, the dial gauge shall be lowered to new position of the cone shaft and the reading note to the nearest 0.1 mm. The difference between the readings at the beginning and end of the test shall be recorded as the cone penetration. The cone shall be lifted out and cleaned up carefully. A little more wet soil shall be added to the cup and the process repeated. If the difference between the first and second penetration reading is less than 0.5 mm and less than 1 mm different from the first, a third test shall be carried out. The overall range is then not more than 1 mm. The average of then 3 penetrations shall be recorded. If the overall range is more than 1 mm, the soil shall be removed from the cup, remixed, and the test repeated until consistent results are obtained. Once the results are consistent, a moisture content sample, about 10 grams, shall be taken from the area penetrated by the cone and the moisture content determined by the oven drying method. The operation described above shall be repeated at least 4 times using the same sample to which further increasement of distilled water have been added. The amount of water added shall be chosen so that a range of the penetration value of approximately 15 mm to 25 mm is covered during the test. Then we will move to determination of liquid limit. Prepare 20 grams of soy paste and split it on the glass mixing plate so it can dry partially. When the soy is plastic enough, roll into a ball using the palm of the hands. When it slightly cracked begin to appear, divide the ball into the portion and it into threads until it crumbles approximately at the 3 mm diameter. First crumbling point is the plastic limit. As soon as crumbling stage is reached, gather the crumble thread and place them into container. Wake the container and dry in the oven overnight. Then calculate the moisture content. The conclusion: Atterberg limits are crucial for classifying fine-grained soils according to the United Soil Classification System. These few moisture contents allow an engineer to know various properties of the sand and how it will act under the pressure of a structure. Atterberg limits also help engineers know what areas to avoid building in due to poor numbers from sample soils. Errors and difference in values between the lab groups are generally due to the qualitative nature of the experiment and the human error that comes into play due to that nature. There could also be small difference in water content due to the amount of time the samples were left in the oven.